Hey, can a hospital run on wind power? Taylor Clark, a frequent guest in IoT Playbook podcast, has done more smart city and smart building projects than anyone I know. But when Taylor Clark sent me an email saying that he got an Atlanta hospital completely off the electric grid and powered by wind, I was skeptical. A wind powered hospital? That's impossible, I thought. And after we recorded this episode, I've become a believer. His solution really works. You got to see it to believe it. And this is one episode you're going to want to see. Taylor shows everything: the business model, the technology, the pricing. It's all in this episode, plus some behind the scenes look at this cutting edge technology. So head on over to podcast.iotplaybook.com and check out this amazing episode. I guarantee you it will blow you away. Hey, this is Mark Smith from IoT Playbook, and I'm super excited about this episode. I'm here with Taylor Clark, the founder of Alternergy. How do you pronounce that?
Alternergy.
Alternergy. Yeah, that's a lot better than what I said. And it's an enterprise level IoT managed service company that architects, manages enterprise class IoT projects, does smart cities, smart buildings, enterprise customers, agribusiness, and more. And Taylor was my guest on episode 8, which talked about smart cities, and episode 9, where we talked about smart buildings. So I really encourage you to go back and listen to those episodes. But actually, when I was asking Taylor for his bio and picture for those episodes, he sent me an email saying that he just completed a project, or was about to complete a project, where he was able to get a hospital completely off the grid using wind power. And I have to admit, when I read that, I'm like, wait, what? Did I misread that? And immediately asked Taylor if he'd be willing to do another episode to talk about this project. So welcome, Taylor, again. And I'm super excited about this.
Thank you, Mark. I'm happy to be here.
So I know you told your story before, but, talk a little bit about how you got into this, IoT opportunity. A little brief background, I think, will help people.
So basically, we've got an agent base that's across the country. A lot of our partners, they're out there in the field already working with clients on either energy savings initiatives, specifically LED lighting, solar powered, or they're just looking to try and do some building management controls. One of our partners out in Minnesota, they have a national reach, but they had a client which was a pretty large hospital. They are a nationwide hospital, and they have a very large one up there in Minnesota. And they wanted to get a quote for solar and try and get off the grid using solar power. When they brought that to us, we were more than happy to do it. We pulled it all together, but we also decided that we would offer the wind technology with them. It wasn't well received at first, but we pushed through and were able to get them convinced on it. But that's how we got the opportunity.
So now, how did you build that network? Because you weren't always leading with IoT as your main thing, right? I mean, I believe in your past you did telecom and you moved to lighting and other things, but now you lead with IoT. What has that done for your business? Is it, has it opened up new opportunities for you that you didn't get before you led with IoT?
Absolutely. So my background, I started my first company in 2004. I started in telecom in 98. In 2004, the company was really a agent channel support company for telecommunications. Mm-hmm. And through that, we built out roughly 300 plus partnerships across the country for people that would bring in telecom service to our business. When I moved into the LED lighting business, I kind of dropped a lot of those agents because they didn't mesh with what we were trying to do with lighting. And as we progressed through lighting to then get into off-grid technology and then into building management controls, and then that parlayed into IoT services. So once we get into IoT to really run all of the services we had been doing to get buildings off grid, those programs and solutions tied back into a lot of our telecom agencies. So for really, when I opened this back up, it brought back all of my agent group that I had back then, where a small number of those guys had energy saving opportunities for me, but most of them now have IoT opportunities for me.
So you kind of pioneered your way from telecom into this whole IoT thing, figured out, and now you've gone back to your original group and saying, hey, come over to the IoT land. There's a lot of opportunity here.
Mm-hmm. Yeah. Absolutely. And most of them were already looking for it. A lot of people that I know have been trying to jump into the IoT space. They just didn't know how. So we really just came out and said, by the way, we're doing IoT. And we can also do a lot of initiatives that are outside of just telecommunications. And that expanded their portfolio and their client base, and most of them jumped on it for us.
Okay, so this particular opportunity, the hospital, what was the problem that they were trying to solve?
They were actually going through some upgrades. And with those upgrades, they were going to have to increase their power supply to the building. They were going to have to increase their backup generators. So they were looking for an alternative. They wanted to go more off the grid. And with that, they just decided to try and interview solar companies to see what they could do for them.
So if they didn't fix this problem, what kind of, were they just going to continue having a certain energy cost thing? I mean, what was the loss they might experience if they didn't fix the problem?
It wasn't really a loss. It was an investment they were going to have to incur.
Okay.
And it was going to be an investment on their parts. They would have to dig up through some parking lots, et cetera, to get that power out there. It was going to be pretty time consuming. And then obviously they would be paying for that power.
Right.
So they might as well go ahead and look at a way to, continue to move off of the grid.
So when you're working with this hospital, who's that person that really is kind of the key driver of this decision, and what were they hoping to achieve? Well, you told me one thing, they want to get off the grid, or at least get close to getting off the grid. Who is that person, and what are they hoping to achieve with all this?
So originally we were dealing with the maintenance engineers. They were the ones that were tasked with it. And then we got to the CTO and CFO and CIO of the hospital.
Okay. All right. And they're hoping to, again, like just get off the grid, or just have a different energy usage profile.
Absolutely. They wanted to become energy independent. They wanted to go green. They wanted to be able to promote themselves that way.
Okay, great. All right, so you've got something to kind of show and tell, because this will be totally new, like wind power hospital. So, why don't you share your screen and kind of walk us through like this case study, and then, get into some of the business model, how this kind of works.
Absolutely. So for your program, I've just pulled together a quick little spreadsheet that will condense most of it, so it'd be easier for everybody that's watching this. And let me see if I can just shrink this down properly. Okay. So what I'll go over here is the initial evaluation for them was obviously what is the power that you guys are currently using. So we took an average of their on-peak hours and as well as their off-peak hours, and we did every month for the entire year. So this is just a quick summary to show how much they're spending every single month. You'll notice that ranges from $60,000 up to $94,000 a month.
Yeah.
And then the kilowatt rate can range, and obviously that depends on peak demand, power consumption, time of year, et cetera. But that would average around 11 cents per kilowatt. So what we were looking at is them spending an average of $71,000 roughly every month and hitting 11 cents per kilowatt. So in 1 year, they're spending roughly $850,000. What we needed to do was come up with a total cost. So we were looking at about 7.97 megawatts that this hospital needed to be completely off of the grid. So we did, I'll show you some of the solar numbers as well, because they were looking at that, but the cost for solar was roughly 3 times as much with a third of the production.
So 3 times as much as they were currently spending.
Well, 3 times as much as the wind solution.
Okay. All right.
So it was a lot more expensive. So when we got there, what we were looking for is how many wind walls would they need? And a wind wall, I'll show you a quick picture of them, and we'll dive in more, is really this device over here on the right. So you'll notice that it has multiple cubes. There's 100 of them. The device in the center that you see on the box, that actually rotates with the wind. So each one of these cubes will max out at 1,000 watts. It only needs 17 miles an hour at max wind speed to get to that. These are going to be roughly, I believe, 35, 40 feet in the air. So when you get to that height in that area, they're roughly always going to be at that production for wind. These devices also, as they stop, are still generating due to the coil and the transformer that are in there. So even when there is a lack of wind, they are still producing energy for a short amount of time. So
interesting. So unlike those humongous windmills that you see like in Palm Springs or other places, I mean, this is dramatically different than that.
Mm-hmm. Absolutely. And we'll show you a little bit more on the comparison of the size, but this is, each one of those cubes is roughly a square foot. So
okay.
11 inches by 13 inches.
And then does the energy that they do, does it get stored in like a battery or?
But it has battery options as well and a tie grid inverter. So depending on what the client wants, it will contain it itself. These are actually magnetic. There's a magnetic force that's held onto it, so they're frictionless on the blades, and they will continue to spin for a very long time, even after once they've been spun up. So they don't need constant wind to keep moving. So what we've done is we produced roughly 10 wind walls is what they were going to do. And each wind wall was going to produce about 2,400 kilowatts per day, which would come out to 24,000 kilowatts per day total. And for the month, 720,000 kilowatts, which was going to give us about 8.64 megawatts. Mm-hmm. They needed about 7.97. So we have an overage of roughly 670,000 watts built into this. Mm-hmm. The total cost was going to be roughly $6 million for the entire project. The ROI is 84 months or 7 years. These come with a 30-year guarantee. But the great thing about it is there's plenty of incentives out there. So there's a 30% tax incentive, which was going to reduce it by about $1.8 million. So that takes the total cost of this project to 4.165. And the new ROI based on those figures means that under 60 months or just under 5 years, they were going to be completely paid off. So the average savings between years 5 to 30 is going to be roughly $21 million that they would be getting. And then let's see here. And then if we wanted to add in some intermittent co-generations, they looked at having a backup for gas. So we do have another solution as well that we brought to the table for them, just in case. Everybody's always worried that what if there is no wind? This is a newer technology. So to come in and give them something that would provide complete backup power, we did a cogeneration unit. So that runs off of natural gas, which means that you're always going to have power that goes in. Natural gas rarely goes out. It only goes out if there's an explosion somewhere, and we know those are very, very far and few between. Mm-hmm. So you get a stable, steady source of power, and you don't have to worry about any type of fluctuations or spikes in the power grid that you would be getting on that. Mm-hmm. So with that, we were looking at roughly another totaling up to about $6.5 million for the project, which brought their ROI to 7.66 years. We got another tax incentive on there, which took it down to 5.36 years. So the savings that they were going to get for years 6 through 30 was about $20 million, adding that on as well.
Wow. Okay. And in terms of managing this thing, since it is newer technology, I'm assuming like how granular can you get in terms of managing down to the individual cube, and is it running and all that kind of stuff?
Yep. There's a monitoring system. It is extremely inexpensive. It's only a couple bucks really per month per unit. So it's very affordable, but it will give you detailed information on every single cube that is inside of all of the walls. Mm-hmm. And you'll be able to watch your power, see what's going on. The maintenance is really an oil change because it's the device that actually moves the unit with the wind. So you need to do that once a year. The maintenance on the cubes themselves is virtually zero. You may have to change out a transformer inside one of those, and that cost is a couple $100, and it's a very easy unscrew, pull out, put it back in, and screw it back in. So that maintenance for long term, even after that 30 years, is significantly cheap.
How did you find this?
So actually, this company came to us through when we were doing our smart city innovations. We had a university that we were working with on designing out a ground-up smart city south of Atlanta. They were partnered with us on some of the original designs, and they have one of these at their facility. It was a 3D printed. It was one of the first units out there, and they started talking about it and mentioned it. So I immediately called up to the company. It took them about another 8 months for them to go out full blown and actually go out and start selling them. They did have some small government contracts they did prior to us coming on board. But right now, this is the first year that they are selling to the public, and they're doing it in a very selective manner. Very few partners and very few clients, just because they want to make sure the rollouts are accurate, they're installed properly, and people understand the technology. And then they're going to get into a much broader and attack all areas at that point for sales.
So what's part of the, so you walk through the wind wall, And you've got another little diagram that says heat and power and whatnot like that. So what's sort of part of that offer then that goes there? I mean, they get the wind wall, they get the obviously the management, because you also have yourself developed like a unified dashboard that they can use. Do you utilize that? That's, I think, it's Azure based. Did you use that in this scenario?
We did not include our own system in there.
Okay.
They have their own BMS. We're looking at potentially moving towards that. But for the moment, we're going to be integrating the existing monitoring system into their platform for them.
Okay. Just out of curiosity, what are they using for their BMS? Is it like Johnson or?
Yeah, actually, it's a Johnson control system.
Okay. All right. Okay. So, what other things have you discovered along the way? I mean, because first of all, your big thing is, getting them to shift over from solar to wind, and obviously the numbers support that pretty dramatically. Was it? And then, how did you prove to them that, hey, this technology will work? Did since it's fairly new, mm-hmm. did they need a lot of proof to just say, hey, this is going to work or something?
They have, but this product itself is published in a few different areas. It's been tested, again, through universities and through several other independent studies. And those are available, and we let them talk to the inventor. And we're going to be actually bringing up a cube for them to play with here in the very near future.
Okay. So how long would you say this will take to implement? Like have they pulled the trigger yet and you're in implementation, or where is it at?
We're expecting a decision. They've pretty much said that this is what they want to do. They're going through the politics of the back end, but we expect that we'll be moving forward by the end of the year or the first part of the first quarter.
Okay. And once they pull the trigger, how long would it take for them to implement and sort of transition from the grid to off the grid?
So right now, because this is a newer technology, everything is being built to suite. It's a 6-month lead time. Installation is only going to take about 20 days.
Okay.
So once we get there, we'll go in, and most of that is really just testing and training, and making sure that everything is working prior to getting out. Getting them installed on the roof and tied into the grid, it really is not that long of a time. So it may be about a week and a half, 2 weeks of install, and the rest is just going to be testing and proof.
So if somebody, what makes an ideal candidate, right? So let's say that somebody's listening to this and they've got a hospital client, or I don't know, maybe another scenario. What's the ideal scenario, both as a trigger point, like you've got a company, like in this case, the hospital was looking to, change some energy infrastructure. What's the ideal candidate for this kind of a solution?
Realistically, anybody that's got a lot of power and is got a little bit of height. The higher you go, obviously, you've got more wind. So this is a 6-story hospital. So obviously there's a lot of height up there, so you're going to get a lot more wind. So high rises and anything around mid to high rises are going to be ideal candidates because you're always pushing the maximum amount of power. But anybody else that really just wants to go green or off the grid is going to be a worthy candidate of it. But you do want them to need, this is our lowest or our smallest unit that they're mass producing right now that you're looking at, the 6 kilowatt version. They do have the single cubes available, but those are only going to be available right now since they're starting up in the 100,000 order. So you want to be somewhere that they need about 6,000 watts or more.
Okay. And in terms of, the big idea, the wind, are you saying like there really is, anywhere in, let's say, the US or Canada could be a candidate? Is there enough wind everywhere, or?
There absolutely is. There are some areas that have more than not, but typically it's just once you get above 20 to 30 feet, you're going to be having a constant wind that's coming across no matter what. That's where the clouds and the atmosphere is moving across. So you do have that consistently the higher up you go. Obviously, you go to a town like Chicago where you have the lake and it's pulling everything in, then you're in a much better spot. So there's topography and demographics and surrounding buildings that may come into play for that. But typically, if you're going to be a little bit higher in the air, or you have the ability to put them on a pole, and you could maximize the output of the machine.
Yeah, because that's one of the, I think just overcoming that sort of, at this point, false belief that, when you've seen these windmills, they've had to be in areas that are just have a lot of wind and they take up a huge amount of real estate. And I always, when I'm driving through Palm Springs and I see hundreds of these things, and a third of them are off. They're not even moving. And I'm thinking, oh, that can't be generating power. You mentioned in this case, you almost need very little wind in that smaller range. And it even continues to work after the wind sort of dies down. How does that work?
So that's a very technical answer that I wish I could explain.
Okay. All right.
But it's basically the way that it's generating the power. It's the coil is not done absorbing the energy once it all hits. So it continues to spin. It continues to hold that into the transformer and push it out. So it does actually hold a load, and that would be available even after the wheel stops spinning.
All right. So if somebody had an opportunity and they thought that their client might be a good opportunity, is there a way to partner with you or reach out to you and maybe pull you in on one of these things, and benefit from your experience in architecting this kind of a thing?
Absolutely. We'd love to look at anything that could make sense for the client. Anybody can feel free to give me an email at tclark, T for Taylor, C for Clark, so TCLARK @alternergy.solutions. There is no .com or .net. So tclark @alternergy.solutions, or they can just call us on our toll-free number and we'll be happy to talk to them then.
Great. And I'll put all that in the show notes. So Taylor, I am amazed and super appreciative of you, walking through this pretty cutting edge, case study here with this hospital. And I'm super excited. And of course, I want to follow up, after it's been implemented and see how things are going and what you guys have learned and stuff. But again, thank you for being here and sharing this amazing, example of cutting edge IoT.
Absolutely happy to do it.
Yeah.
And one thing to mention is that we were able to really pitch this on an as a service model.
Oh, yeah. Okay.
Most likely they'll be doing that particular part of the project, which is a 10-year payment plan. Their power bill right now is roughly about $75,000 a month. Their monthly payment on the as a service is going to be around $30,000 to $33,000,
which is less than they're paying now.
Mm-hmm. It's about half of what they're paying in power.
Okay.
So they will be cash positive month one when they start doing this. They'll never actually go negative on balance.
So, okay, that's an amazing business model. And did you bring in, I know in your previous episodes, you talked about bringing in like Lloyd's of London and stuff as your finance partner. Is that who kind of helped put this
They are the backer. We deal with an independent agency and somebody that I've dealt with for a very long time. He was actually an LED manufacturer back in the day, but he's got a lot of banking relationships and was able to pull together an as-a-service model for us about 5 years ago for lighting. And we were able to parlay that into our IoT space. Okay. And really almost anything that has a savings over the cost, we can put into an as-a-service model. So it's not just limited to this particular item.
So because normally in the old days, right, this would be a big CapEx deal, and they'd have to go and get a lot of, millions, $4.5 million of funding up front. Now you spread it out as a service. Who assumes that risk if the client says, hey, this isn't working or something like that? I mean, like, how does that risk get shared?
So it is backed through the insurance company, and basically the insurance company vets out the product to a very granular level. They will actually cover costs if the machine itself fails. So they're completely covered in that particular aspect. And they would also look at potentially doing a refund if it got to something that was just disastrous. We've never experienced that. That's there. So they know that they're getting guaranteed savings.
What kind of insurance company handles something like this? Because this is pretty cutting edge and I think unique. Are there insurance companies in the energy space, or how do you find someone like that?
It's a unique agreement with Lloyd's of London that was set up through the banking relationship.
All right. So if somebody, again, it's not just the technology, it's the entire business model, it's the architecture, it's everything, which is why somebody talk to the listeners here, viewers, if you get an opportunity like this, it really is good to partner with somebody who's figured out all those moving parts. So again, and thank you for bringing up the extra part of the business model, which I think is absolutely critical.
So what I'll do real quick is kind of go through some of these slides and explain a little bit more and show you some demonstrations of how the product can look. But I do want to go through each one of these cubes itself. Like I said, can do up to 1,000 watts per cube. And that's at 17 miles an hour. The main key component for this is because it's magnetic and frictionless, it can generate power as low as 1.5 miles per hour. So that's a huge advantage over a large windmill, which may be 8 miles, which is kind of on the best scenario, and 15 miles being more average before it'll start kicking up anything. It is completely maintenance free. The snow won't stop it. It'll just keep spinning and go off of it. They haven't had any issues, and they've been in some of the harshest climates imaginable as far as what this can do. It's also animal friendly. Birds cannot get killed. They will just bounce kind of right off the center of it. And the engineer, the inventor that made it, he's an aerospace engineer. So he designed the propellers similar to jet engine propellers to get the best friction to do it. And he's also using literally a polymer that NASA uses. It is just as strong as steel. It is literally bulletproof. You could shoot the same spot 3 times in a row, and it would just put a minor dent into it. But it is lighter than aluminum. So this product is amazingly robust. And these drawings right here are just drawings because this is a new rollout they were able to do. What you'll notice is they're just stacking them together, and you've got over to the right a little knockout so you can continue to adjunct these together. You could also stack on top of them. So that's the 6 and the 9 kilowatt, 18 kilowatt. You can see just kind of keeps adding to it. Then it goes up to a 27 kilowatt machine. And then I'll start showing you some other pictures here. So the individual cube is on the left. The WINDWALL, which is just a set-in-place WINDWALL, is up on the top right. The advanced WINDWALL, which is what we're selling to the hospital, is the one on the bottom left corner, and that's the one that actually moves with the wind. And then they also have single units for the microsphere. That's got a tail on the back, so it actually swings with the wind. But again, the single units, they're not looking to produce those right now until they get to larger orders, minimum 100,000 each.
Okay.
So MICROCUBE is 1 kilowatt each, roughly about 6 amps on max, and they weigh about 9 pounds. So they can actually handle up to 100-mile-an-hour winds as well before you have to take them down. Some are rated for up to 140. So depending on what you've got, but these are basically hurricane force winds that these can withstand. And they can get up to a category 2 or 3 before you need to pull them down. We'll show you a picture here of the WINDWALL. Again, this is the stationary WINDWALL. The advanced WINDWALL here, again, 900 pounds for this unit, can pull up 100,000 watts. That's just a good picture of it. We'll go through some of the advantages. Again, size, volume, wind speed. It's quiet. There's limited drag. It's environmental, wildlife friendly, as we talked about. So we'll see here. We'll show you there are basically 9 inches for what this cube is going to do in diameter. And you can see that the other turbines out there range from 6.5 feet to 9.1 feet.
Wow.
So when you're comparing that to size, you can look at a scale representing our advanced WINDWALL next to the person on the left. To produce the same amount of power, you're looking at the turbine in the center, and then you're looking at what a 100 kilowatt solar farm would be needed for.
So when you hear the sort of anecdotal argument about, well, you need to power the U.S. with wind, you need to put that second wind thing over the entire state of Texas. With this new WINDWALL, it's a bit of a game changer.
Yep. Yeah. Everybody's got their position on, ideas like the Green New Deal, et cetera. But this particular unit would actually take people off the grid. This can further the off-grid and green technology and really eliminate the need of a grid on new build-outs and retrofitting. Absolutely.
Huh.
Again, you can just kind of a quick loss. You'll see that you lose all of that energy with the wind with these turbines just simply because they're not handling. There's only 3 propellers, whereas ours has propellers all the way through it. Again, our wind speed is the best, under 4.5. Let's see here. The national average is 4.7 miles an hour, just as an FYI. So, with that, you're not going to hit any type of turbine that's out there originally with that 4.7. With the WINDWALL, you will.
So that's that 4.7 miles an hour average. Is that at 30 feet high, like your optimal thing, or is that just in general?
That's in general. That's down to the ground.
Yeah.
Again, the only thing you'd have to do for environmentally friendly is a core exchange, which is every 30 years. And that is an extremely inexpensive process, and it's very quick. So once you've put the initial investment in, let's talk about solar. You put the investment into solar, you're going to have that degradation. Over 30 years, they're still going to work, but they're not going to work nearly as well. And then once they're done, the dirty thing about solar that nobody really talks about is they cannot recycle solar panels. Nobody knows what to do with the panels once they're done. So granted, people can continue to use them. There are satellites that are in space that have been using solar for 30, 40 years, and they are still operating. But you're losing that efficiency. And again, if we flooded the entire country with solar panels, there's going to be a huge concern as to what do we do with these panels once people want to upgrade or start trashing them. You simply cannot throw them into the trash.
And with this, I mean, like because it's cube, like Lego blocks. I mean, if one thing happened to go out, you can hot swap it, right? And the rest of the unit stays up. You can hot swap out one cube and pop in another one and then fix it. And then, I mean, does it work that way?
Absolutely.
Okay.
Absolutely. Yep. Every one of these has its own independent transformer and generator. So you know, one could fail and you would be able to swap that out without losing the ability to have the rest of the power running.
And then the IoT part, right? I mean, since every cube is probably monitored with everything you can imagine, you know, you're going to hear alerts and maybe even sort of preventative deal, like if there's some sort of warning sign on some thing like temperature or something, you're going to be able to see before it even goes. Yeah,
absolutely.
Okay.
So here's just an example of one of the monitoring pages that you've got in the system. But it'll tell you what each one is generating. It'll tell you when it's not pulling right. Obviously, if the power is spiking or there's one that's just not producing as much power or it's fluctuating, then it knows that obviously that there's something wrong with that particular unit, and it's going to let you know. It can send you a text message. It can send you an email. And then when we add our system into it, we can add phone calls and then actually reactive measures to where it kicks on an alternative generator. This particular hospital, they have 4 different types of power once this is installed. They're going to have the wind walls that we're putting up. They're going to have the cogeneration, the gas lines that are coming in. They are still going to be tied to the grid and will be able to use the grid power whenever they need it. And then they'll also have their own backup generators, which are still in process.
Very cool. Yeah. So, and then of the sort of, you know, it's as a service and stuff. So there's a piece of that fee is just for ongoing monthly recurring revenue management for you. I mean, I don't know what percentage of that, if you want to disclose. I mean,
you know, it's really, we're not, it's just a couple dollars per unit. We're not trying to make a lot of money on it. We have the ability to mark that up if we want it. But honestly, right now, our goal is to continue to grow that management platform inside there. So we just have a little bit of commission built in for ourselves that would just maintain the ability for us to go out there and do any type of management that we need without incurring additional charges to them.
Right. So this is, in some sense, this is a showcase deal to where this, you know, this could be a great case study for doing this all over the place.
Absolutely.
Yeah. Okay. That makes sense. Well, great. Super cool. Again, thanks, Taylor, for this. And I look forward to hearing more. And feel free to pitch me anytime on this kind of cutting edge solution because I love it. So thanks again, man.
Absolutely.